Hey everyone, thanks for tuning in. Today what we're going to be looking at is given one trig function, find another. So this is kind of the almost forgotten part of trigonometry. So throughout this lesson I'll just be taking you through 3 examples and and show you the general approach and how to do these kinds of questions because they are quite easy to forget, although if you do remember the process, they are quite easy. So they all follow this basic structure, okay? And so this question reads, if cos theta equals 4 over 5 and sine theta is less than 0, we need to find tan theta, okay? So first off, we're given this information that cos theta is equal to 4 over 5, okay? And just remembering the definition of sine, cos, and tan, we're dealing with right-angled triangles here. So what I'm going to do is I'm going to construct a right-angled triangle. And, well, I've labeled my theta over here, okay? And by the given information, we know that cos of theta is equal to 4 over 5. So by the definition of cos, we know cos is adjacent over hypotenuse. And so we've got cos of theta is going to be 4 over 5, which is adjacent over hypotenuse. So relative to this theta here, the adjacent side, which is this side over here, is going to be equal to 4, and the hypotenuse is going to be equal to 5. Okay? Now it's up to us really to find this missing side. Okay? And how are we going to do this? Well, we're going to use Pythagoras' theorem, which states that a squared plus b squared equals c squared, where a and b are these two sides here, okay, of a right angle triangle, and c is the hypotenuse, okay. So by applying this, we know that well, let's say this side here is a, so let's say a squared plus b squared, which is going to be 4, so 4 squared is equal to c squared, which is 5, so 5 squared. A squared plus 16 equals 25. A squared, by subtracting 16 on both sides, we know that a squared is equal to 9. And by square rooting both sides, a is equal to 3. Okay, it could be equal to plus or minus 3, but we know this is a length here, which must be positive. So we'll fill that in and write a 3 in there. So, okay, where do we go from here? Well, hopefully it's pretty simple to tell that to find tan theta, we're just going to be looking at opposite over adjacent. So it's going to be 3 over 4. But we do need to take a little bit more care because of this condition over here, that sine theta is less than 0. Okay. Now this goes back into, the ASTC rule. And if you're unfamiliar with this, I highly suggest you look at my previous video that I made on the ASTC rule. So what we have is that sine theta is less than 0. And by the ASTC rule, sine theta is less than 0 in other words, it's negative in the third and fourth quadrant. Okay? And what we have as well is that cos theta is 4 over 5, or in other words, it's equal to positive 4 over 5. So where is cos theta positive? And that's in the first and the fourth quadrant. So we have this condition here which restricts it to the first and the fourth quadrant, and this condition here which restricts it to the third and the fourth quadrant. So which quadrant satisfies both conditions? And that is the fourth quadrant. So what we got to do is make a little statement. We say, since cos theta is greater than 0 because it's positive 4 and 5, and sine theta is less than 0, theta is in the fourth quadrant. Therefore, tan theta is less than 0 because in the fourth quadrant, tan theta is indeed less than 0. Okay. So once we've got this, then the rest of it is going to be pretty simple. So all we need to do is we just need to say, well, tan theta is equal to 3 over 4, and that's by the triangle. So opposite over adjacent, and we just pop in a negative in front of there because it's in the fourth quadrant. Okay, so hopefully that makes sense. we've got two more examples that we're going to look at. Alright, so the second example is this one over here, which says find sec theta given that cot theta is equal to 9 over 40 and theta is reflex. Okay, so if we are unfamiliar with what sec theta and cot theta are, I highly suggest you take a look at my video I made on trig identities. Okay, but basically sec theta and cot theta are the reciprocals of cos theta and tan theta. Okay, so we know cot theta is equal to 9 on 40, and ordinarily that would imply that tan theta, because it's the reciprocal, is 40 over 9. And what do we know about tan theta? That's opposite over adjacent. Okay, so I'll just make a little note down here and say that tan theta is equal to 40 over 9. So that means that opposite over adjacent is 40 over 9. So 40 over here and 9 over here. Yet again, by Pythagoras' theorem, we solve for the hypotenuse here. So we can make a little statement by Pythagoras' theorem. We know that 40 squared plus 9 squared is equal to our hypotenuse squared, so let's call it c squared. Alright, 40 squared is going to be equal to 1600. 9 squared is 81. That's equal to c squared. So we've got c squared is equal to 1600 plus 81, which is 1681. And basically c is the square root of this, okay? And that's going to be equal to 41. Alright, so we fill in that there. So after this, it's the same process. So what we notice is we want to find sec theta, and cot theta is greater than 0. So basically tan theta is greater than 0. So where's tan theta greater than 0? And that's in the first and the third quadrant. And then we know that theta is reflex, which means theta is greater than 180 degrees. Okay, which then implies it must be in the third and fourth quadrant. So we can make a little statement, since tan theta is greater than 0 and theta is reflex, theta is in the third quadrant. Therefore, so we need to find sec theta, which is basically cos theta. So we make the statement cos theta is, well, in the third quadrant, cos theta is going to be less than 0. So then we can make a statement by the triangle. Now by definition, cos theta is adjacent over hypotenuse, which we see is 9 over 41. So cos theta is equal to 9 over 41, but it's going to be negative 9 over 41 because of what we said up here and here. So then we need to just find sec theta, and sec theta is the reciprocal of cos. So we say sec theta is equal to 41 over 9, negative 41 over 9. Okay, hopefully that makes sense. The third and final example that we're going to be looking at is this one over here. It's pretty similar, but it basically says find cosec theta given that cot theta is 2 on root 3, and we have this domain for theta. Okay, so we're given that it's between negative 90 and 90 degrees. Okay, so if we look at our little axes, remember that we read the angle, positive angles, from the positive direction of the x-axis, and we read it counterclockwise. So we read them this way. And this is 90 degrees up here, and negative 90 degrees would be in a clockwise direction, and that would be from down here. So hopefully you can see we're dealing between these two quadrants, which is the first and the fourth quadrant. Yeah, so we're dealing with the first and the fourth quadrant. Okay, and this will be useful for later when we need to make some sort of statement like this, like we did here. All right. So first things first, we're going to use the information given that cot theta is equal to 2 on root 3, and remember cot theta is the reciprocal of tan theta. So that means tan theta is root 3 over 2. So just flipping that fraction. And we just fill in this information here, so that leaves root 3 and then 2 over there. By Pythagoras theorem, same thing, by Pythagoras theorem, we know that root 3 squared plus 2 squared is equal to c squared, where c is going to be the hypotenuse of the triangle. Root 3 squared is 3, plus 4 equals c squared, so that means c squared equals 7, and we have c equals root 7. Okay, so this over here is root 7. Then we make that little statement and we say, since cot theta, which implies tan theta, okay, so we can say tan theta, but since cot theta is greater than 0, okay, is greater than 0, and negative 90 degrees to theta to 90 degrees, so that basically means it's between the first and the fourth quadrant, as we saw here, and the fact that cot theta is positive, okay, that implies that theta is going to be in either the first or the third quadrant. So which one satisfies both of these conditions? And that's the first quadrant. So since this theta is in the first quadrant, okay, so I'll just clear that. Okay. Alright, and then we make the statement, therefore sine theta in the first quadrant is going to be greater than 0, because we need to find cosec theta, which is basically sine theta. Yet again, please visit the trig identities video I made if you are unfamiliar with why this relates to sine theta. Okay, it's not equal to sine theta, but it does relate to it quite heavily. So then we say, we can say by the triangle, rather, so by the triangle, sine theta is equal to opposite over hypotenuse, so root 3 over root 7, okay, and this is going to be positive because sine theta is positive. Therefore, cosec theta, because it's the reciprocal of sine, is root 7 on root 3, okay. So that's basically it. So that was given one trig function, find another. Okay, so like I said at the beginning, it is a little bit of a forgotten topic amongst trigonometry, although hopefully you can observe that it's quite simple actually. So don't forget it, because these can be very easy marks if they were to come up in an exam. Alright, so I'll leave you with that and enjoy.